To most of us, the housefly is little more than an annoying insect that buzzes around in the warmth and shelter of our homes. It bothers us especially when we find it in the kitchen, on dishes and food, but otherwise it seems simple and insignificant. Yet the housefly is amazingly complex, and it can be a deadly menace. A master of flight, the housefly is agile and fast, and very difficult to catch. When it flies, its wings beat more than 200 times every second. The up and down motion of the wings is controlled indirectly by flight muscles in the fly's midsection, or thorax. The thorax moves up and down a mere fraction of a millimeter. These tiny movements are transferred to the wings along a series of hinge-like joints and amplified several hundred times by the wings. The number of wing beats can be measured by the tone of the hum. The higher it sounds, the faster the wings are beating. During flight, the legs are held close to the body to decrease air resistance. The wings constantly change their angle of thrust. This wing motion lifts and propels the fly through the air. The fly's wings are translucent and well adapted for rapid flight. The efficiency of each wing is increased by bristles on the leading edge. Minute hairs on the wing surface probably contribute to efficient airflow over the wing. The row of hairs on the trailing edge of the wing enlarges the surface slightly. Behind each wing is a halter, a vestigial wing, that acts as a flight stabilizer. The halters relay information about the fly's position in flight. The delicate antennae sense the airstream during flight, enabling the fly to control its airspeed. The many-faceted compound eyes aid flight by providing the fly with a panoramic view of its surroundings. The fly also has 3 ocelli, simple eyes, that sense differences in light intensity. Rapid extension of its legs enables the fly to land on any available surface instantly. To land upside down, the fly first extends its forelegs upward to make contact, and then swings the rest of its body into place. But how does the fly stay upside down? If we look at the fly from below, through a pane of glass, we see on the tip of each foot, or tarsus, a pair of claws, which enable the fly to cling to rough surfaces, and a pair of tarsal pads for adhering to smooth surfaces. The tarsal pads are covered with many fine hairs, the ends of which hold a sticky fluid. When the fly removes its foot from the glass, the droplets remain. As we've seen, the housefly is well adapted for flight. It is also well adapted for feeding, in ways that seem unusual to us. To find and recognize its food, the fly has scent and taste organs. The scent organs are on its antennae, which are covered with sensory hair and olfactory pits. We often see flies standing on their food. Flies not only can taste with their mouths, but with their feet as well. The tarsi of the front legs have taste organs. The fly's proboscis, or feeding organ, extends from the head when the fly finds food. The end of the proboscis expands into two lobes. Here we see the lobes from below. Each lobe contains a system of channels stiffened by thin braces. By means of the channels, liquid food like this drop of sugar solution can be quickly absorbed. Some solids, like this grain of sugar, must be dissolved first. The fly secretes saliva onto the food. The liquefied food can be sucked up, pumped by a special set of muscles in the head. Because the fly can liquefy many substances with its saliva, it can find nourishment almost everywhere. The housefly not only feeds on our food, but also on garbage. It also feeds on manure. Fly larvae help us by breaking these wastes down. However, disease germs from the wastes stick to the body of the adult fly. Because of this, the fly contributes to the spread of disease. The housefly and close relatives like the face fly spread disease to livestock. Fly-borne disease germs can easily infect the body through an open wound. Flies transmit germs of cholera, typhoid, dysentery, polio, and many other deadly diseases. Millions of microbes are excreted with the fly's feces. Using a microscope, we discover a variety of fungal spores and bacteria in the feces. Microbes also stick to the fly itself. In fact, it is covered with them. When a fly walks over a suitable culture medium, it leaves a trail of bacteria, which soon develop into colonies. Using time-lapse photography, we can watch the growth of a bacterial colony that develops in the trail of a fly. The adult housefly feeds on garbage and waste. So do its offspring, which begin life in their source of food. The housefly begins as an egg laid by an adult female. She probes for a suitable location for her eggs. The female extends her ovipositor like a telescope to deposit the eggs in a source of food for her young. She lays them under the surface to safeguard them from enemies and dehydration. The tip of the ovipositor carries sense organs, which enable the female to lay her eggs side by side and in the right place. She lays about 120 to 150 eggs in a single batch, and 4 to 5 batches during her short life. After about 24 hours, The fly larvae, called maggots, hatch from the eggs. A slit at one end of the eggshell eases hatching. Maggots have no legs. They crawl by using powerful muscles which contract and extend the body, by using hook-shaped mouthparts at the pointed anterior end, and with the assistance of spines on their bodies that give traction. The maggot has no eyes. On the blunt posterior end are two dark spots. The spots are breathing pores, or spiracles, that lead into a complex system of air tubes. Delicate hairs keep out dust and liquid. By keeping garbage near our homes, we offer the fly a most favorable environment for its offspring, virtually on our doorsteps. Depending on the availability of food and on temperature, after about 5 to 6 days and 2 molts, the mature maggots are ready to pupate, a major step in their transformation into adults. This process takes several hours, but is shown here in several seconds through time-lapse photography. The pupa case, which is formed by the hardening of the final larval skin, is a small barrel-shaped container. Inside the pupa case, the metamorphosis from maggot to fly occurs. Special photography enables us to see the fly's heartbeat inside the pupa case. When the metamorphosis is complete, the adult bursts the lid of the pupa case, aided by a balloon-like tilenum on its head. When this sac expands, the head swells to about twice its normal size. The tilenum acts like a bulldozer, pushing open a path to the surface. By alternating expansion and contraction of the tilenum, the fly can reach the surface. Its spindly legs are of little help in this process. Once on the surface, the fly immediately begins to groom itself. The tilenum disappears, withdrawn into the head, never to be used again. As is true of all insects, the behavior of the housefly is purely instinctive. The fly is taught nothing. Its every act is an innate mechanism. On the average, females will live about 4 to 5 weeks, males only 3 to 4. The adult pumps blood into its crumpled wings to expand them. Then the wings stiffen. The exoskeleton soon hardens and darkens. The fly is ready to take to the air.